Hello students, welcome. Today's lesson is on word problem involving linear equations. By the end of this lesson, you should be able to convert word problem involving linear equation into mathematical symbols and solve them. Before we start, let's quickly dive into what we know already to help us understand what we don't know. In our previous lesson known to be linear equation, I made it clear that if you have, let's say, 2x minus 3 is equal to 1, then for this case, the entire expression here is known to be linear equation or equation. You can also call it as formula. So you call this formula or equation. Why are we saying it is formula or equation? Because it has a coefficient and variable as well as an equal to sign. Now, this expression, this equation or formula could be solved by making x the subject. That is traced from the knowledge of change of subjects that you have done already. Now, to solve this, we know that 2x minus 3 is equal to 1. We are trying to make x the subject at this moment. Therefore, 2x will be here equal to 1 plus 3. 2x is equal to 4. Therefore, we divide through, leaving x equal to 2. Now, this is how we deal with equations. When you get an equation, this is how we solve. We just try to make x or the variable the subject using the knowledge of change of subject. Now that we've recovered what you know already, let's base on that knowledge to understand word problem involving linear equation. In mathematics, word problem is question composed of one or more sentences that ask students to apply what they've learned in the subject to a real-life situation. Now, before we start the actual word problem involving linear equation, let us be familiar with some of the words or phrases associated with word problem involving linear equation. For addition, the following are words or phrases that whenever you see in word problem, then you are to add. So the words or the phrases are total, sum, together, increased by, more than. So these are some of the words or phrases that whenever you see in a mathematical word problem, then you must think of addition. So the words are total, sum, together, increased by, more than. There are more, but we should be familiar with these popular ones. Now, let's quickly dive into the words or phrases that whenever we see in mathematical word problem, then we think of subtraction. Subtraction. So what are some of the words that whenever we see in mathematical word problem, then we should think of subtraction or minus? So this is subtraction. And had a sign of this. This one was addition. It had a sign of this. So the words or phrases are, we will see difference. We will see reduce. We will see fewer. We will see decrease by. So these are some of the words or phrases whenever we see in mathematical word problem involving linear equation, then we should think of subtraction, that is minus. Without wasting much of our time, let's quickly dive into some of the words that whenever we see, we should think of multiplication. So for multiplication, these are some of the words that you will mostly see. We have product. We have group of. We have lot of. We could see multiply and more. So whenever we see any of these words in a mathematical word problem, then we should think of multiplication. Quickly, let's move on to the aspect of division. What are some of the words that when we see in a word problem, then we should think of division? So for division, we will mostly see these words: share, you will see split, you will see pair, then we see quotient. These are some of the popular phrases or words that whenever you see in a mathematical word problem, then you should think of division. Now, let's quickly move on to some of the phrases or words that when you hear or see in a mathematical word problem, then we should think of equal to. So the words are results. When you see result, means you have to use the sign equal to. And you see is, then it's supposed to go with equal to sign. Then if you have will be, then this also goes with the symbol equal to sign. Now the question is, how can you solve word problem? I'm going to teach you two simple strategies that can be applied to many word problems before solving them. The first strategy, I've named it to be, what do you already know? So what do you already know? Then the second strategy is joining pieces together. Now, in order for you to understand these two strategies very clearly and deeply, then let us consider the examples that are on the next page of this sheet. Example 1. 15 more than 3 times a number is the same as 9 less than 6 times the number. What is the number? So the question is saying 15 is more than 3 times a number. Now, before we start solving the example 1, let us consider the two strategies that I talked about earlier on. The first phase of that strategy is that what you already know. So from this example, what are some of the key phrases that you already know? So to solve this, you do it before you come to the actual solution. So before you solve this, now what do we know from these particular sentences? Now we can see 15. So 15, we know that 15 can be written as 15. We know this already. Then we could see more than. Remember, from the previous section, we said that more than means we are to introduce addition, so plus sign. So more than means we are to introduce plus sign. Then from this phrase, 3 times a number. So 3 times a number. 3 times a number is equal to 3 times a number. We don't even know the number. So let us write what we know. 3 times a number, meaning 3 times a number. That is what we know. Then the other one is, we can see S, and tracing it backwards, S represents equal to sign. So S is equal to the equal to sign. Then the other one is 9. You can see 9 here. So 9, and we know 9 could be written as the 9 we know. Then we could see 6 times a number. 6 times a number. Remember, we have less than, 9 less than. So less than, and tracing from here the phrases that I wrote, less than means it is under subtraction. That is decreased by or less than. It is all under subtraction. Therefore, less than could be represented by a minus sign. Then we have the other phrase to be 6 times a number. That is 6 times the number. So we know already that 6 times a number is equal to 6 times the number. 6 times. These are what we know, and we will do this before we start the actual solution. Remember, you could do this in a rough sheet. So 6 times a number, we've written it. Then looking at it, the final phrase is that what is the number? So what is the number? And finally, we don't know the number. So let's represent it with the use of. Now that is the first aspect of it, what you know already. So let us consider joining pieces together. So to join the pieces together, we have to be sincere here. Let me demarcate this section to be used as joining pieces together. So to join the pieces together, it is very simple. It could be done by saying 3 times the number. 3 times the number plus 15 is equal to 6 times the number minus 9. So looking at the phrases here, 3 times the number, 3 times the number, this is the 3 times the number, plus 15, then is equal to, so whatever that we write here, it is the things that we wrote at the beginning section that we are just trying to join them together. That is all. We are adding nothing new. So 3 times the number, 3 times the number plus 15 is equal to 6 times the number minus 9. Minus 9. Remember, it's supposed to have been in a sequential order, just as the question has been, because I'm supposed to have written it 15 plus 3 times the number, which is equal to 9 minus 6 times the number. But the reason is that looking at the actual question, it is saying 15 more than 3 times a number. When you say something is more than, then it means that there is an existed object over there and we are trying to add something to it. We are having more than, we are trying to add something to it. So if you say something is more than, it means that there is an existence of that thing before the additional one comes to it. So if you are writing it mathematically, then the existence, the already existed object has to come first. That is why 15 is more than the already existed 3 times the number. Let us be clear of this one. 15 more than. So the 15 come after the 3 times the number. So the 3 times the number is already existed. And we had an additional one attached to it, additional 15 to it. So you have to first write the already existed object or the number before you add the additional one which was attached to it. That is the reason why I did not write it 15 plus 3 times the number. If I write it like that, it will be correct because addition is commutative. But when you come to subtraction, remember subtraction is not commutative. Therefore, if I write it 9 minus 6 times the number, our solution will be wrong. So we must always consider the phrases. We are not trying to convert them word by word. That is not what we mean here. But as we are trying to convert them using the mathematical symbols, we have to try to understand the actual question as well. Now that we've joined the pieces together and we've done what we know already, that is this section. Remember, both of these is done on a rough sheet. We don't do it as part of our answer booklet. We do it on a rough sheet. Now that we've done this, it's up for us to do the actual solution. And the actual solution is deduced from the joined pieces that we've had here. Therefore, you have to rewrite it again. But remember, since we have written 3 times a number, let us represent the number by any variable at all. So for me, I could represent the number by p. So I can say that let p represent the number. Therefore, to solve, you write 3 times, now the number is p, and plus 15 is equal to 6 times p minus 9. So it will be 3p plus 15, which is equal to 6p minus 9. At this juncture, I would like to let the p, this 3p come here, and this also come here. Therefore, it will be 15 plus 9, which is equal to 6p minus 3p. Therefore, 15 plus 9 will give us 24, which is equal to 6p minus, 6p minus 3p will give us 3p. Therefore, dividing through, we will get 3p equal to 24. Divide through by 3, divide 2 by 3. Now p is equal to, this will give us 8. Then we conclude by saying, therefore, the number, remember, from the question, there is nothing like p. We just represented it by the number. So we conclude by saying, therefore, the number is 8. Since there is no much space here, that is why I've written this way. You can pardon me for that. So there is the answer for number 1. The number is 8. Example 2. When a certain number is decreased by 12, the result is 3. What is the number? So for this one, we will still apply solution. So for this one, we will still apply the two strategies. That is what we know already and joining pieces together before we come to the actual solution. So what we know already from this particular word problem. What do we know from this word problem? We could see when a certain number is decreased. So the word decrease here means what? If you trace it from this section, decrease, we trace it from here, then decrease by, that is subtraction. So decrease, that is subtraction. Decrease is for subtraction. Then it's decreased by 12. We know that 12 is equal to this number. Then you could see the result in mathematics means equal to, then the result, then 3, you could see 3. Remember, we do this somewhere in our rough sheet. So 3. Now then the final one is, what is the number? For the number, we don't know the number. So this is what we know already. That is the first phase of the strategy. The second phase is that we have to join the pieces together. So to join the pieces together, it has to be a certain number is decreased by 12. Look at this phrase. It's decreased by 12. It means that there is an existed number there, and the existed number was decreased by 12. So if we go word by word here, then we could write it as a certain n minus 12. You could write it as n minus 12, and that is wrong. Remember, it is decreased by 12, so it has to be 12 minus the number. But it is not the number minus 12. If you go by word here, you always be mistaking some of the phrases with the other phrases. What I mean is that aside you writing what you know, when it is time for you to join them together, you have to always understand the sentence itself. Remember this one, when a certain number is decreased by 12, look at something. The 12 is already there. The 12 exists, and it was decreased by a certain number. Therefore, you have to write the 12 first minus the certain number that was decreased, and the result, which is equal to 3. So we have joined the pieces together. The 12 is here, minus is here, number is here, we don't know, equal to, that is the result is here, and the 3 has also been written. So now that you have done this rough work here, you base on this to do the actual solution. And the actual solution, you always start by saying, for this case, I will let Q be the number. Now we are writing this. We have 12 minus, now the number will be replaced by Q, which is equal to 3. So we could let the Q come here, which is equal to, we let the Q come to this side, and we let the 3 come here, which is equal to 12 minus 3, because it was positive, it crossed, it will be negative. Then Q is equal to 9. So you conclude by saying, therefore, the number is 9. That is it. You are done with it. Let's quickly dive into example 3. The example 3 is saying when 5 times a certain number is increased by 3, the result is twice the same number increased by 12. Find the number. So for this case, solution. To solve this assignment 3, you must still think of the two strategies involved when solving word problem involving linear equation. And the first one is saying what you already know. So from these sentences or from this word problem, what do you know from this word problem? Now, to tackle that one, we could see that when 5 times, so we know 5 to be written as 5 could be written as 5 as we see here. When 5 times a certain number is increased by 3, so increased by, we know of increased by. Increased by. And in mathematics, if you see increased by, then it means that we are talking about addition sign. And saying it is increased by what? 3. No, 3 could be written as 3 as we see in terms of number. Then, when it was increased by 3, the result is twice the same. The result, we know from mathematics that result means equal to sign. Then, the result is twice. If you see twice in mathematics, then we are talking about 2. Twice. Then it is twice the same number increased by 12. So 12 is equal to 1, 2. Then finally the number. Remember, we don't know the number, so we represent it by a question mark. So for this one, now we have dealt with what we know already. These are what we know. And the second aspect is that we have to join these pieces together. Remember, we are doing these strategies in a rough sheet. This shouldn't be part of your answer booklet. So we have to join the pieces together. So to join the pieces together, we could say that we have 5 times the number. Now we don't know the number at this juncture. Plus 3. So 5 times the number plus 3. And the result, that is the equal to sign. And the result is twice the same number. So twice, 2 times the number plus 12. So this is the pieces we've joined from what we know already at this juncture. 5 times the number, 5 times the number, 5 times the number, plus 3, plus the 3 here, equal to 2 times the number plus 12. So since we've written the joined pieces together, let us go into the actual solution. The actual solution is that we first have to represent the number. So let the number be, can use m for the number. No, variable is not only x and y. So let the number be m. Therefore, 5 times m plus 3 is equal to 2 times m plus 12. So this will be 5m plus 3 equal to 2m plus 12. Now 5m is here. We transpose this one 2m to this section, leaving 12 minus 3. You get 3m, which equal to 9. Divide through by 3, divide through by 3. Therefore, m is equal to 3. Now, we conclude by saying the number is 3. This conclusion is very important and crucial because from this example, we did not see m. M is not part of the example. You introduce it yourself. Therefore, you use it to solve to get your value for the number we are looking at. So after you are done with it, you have to let the number correspond to the answer you got. That is as simple as A, B, C, D. At this juncture, for the sake of time, I will pause here. On your own convenient time, try your hands on this assignment. Assignment 1. John is twice as old as his friend Peter. Peter is 5 years older than Alice. In 5 years' time, John will be 3 times as old as Alice. How old is Peter now? This is assignment 1. Let's go to assignment 2. When x is divided by 13, the quotient is 9 and the remainder is 3. Find the value of x. Assignment 3. A train fare for a school child is half the fare of a teacher. The total fare for 120 children and 15 teachers for an excursion is 180 Ghana cedis. The question is, I. Find the fare of a child. I. How many children will go on the excursion with 20 teachers for a total fare of 240 cedis? Now, to submit the given assignment and to solve more challenging questions relating to this particular topic, that is word problem involving linear equation, then visit the link on the About page of this channel. Click on the link to join a group of serious mathematics students just like you on WhatsApp. I created the WhatsApp group purposely to guide students all over the world through mathematics and to help solve their assignment and any other challenging questions with ease. If you are new to this channel, consider subscribing and turn on the bell icon so that you'll be the first person to get notified anytime I release new video. Like this video to help YouTube suggest my videos for other students on this platform. Tell me your thoughts about this video in the comment section below. Finally, share the video to your friends to whom may find it helpful. I am Dennis. Tuto is my jargon. Thanks for watching this video and stay blessed.